Hey everyone, thanks so much for taking the time to make the trip out to see this talk. But seriously though, we hope you and your loved ones are safe and healthy during these unusual times. So today we're going to be talking about Eradicating Vulnerability Classes by Shelving SAST and Embracing Secure Defaults and Invariants. So this talk is going to take a bit of a different angle than many tools, talks, and really the industry as a whole. So there's a number of benefits to this different approach we're going to be describing. First is that it's going to enable us to focus on killing bug classes rather than one-off ad hoc wins. And this enables us to be very scalable and systematic as AppSec programs and really get some nice long-term wins. We're going to talk about how to enable developers to move fast and securely, and how the security team can be business enablers, not another point of friction. And most importantly, we're going to talk about a methodology, as well as some concrete action steps on how to do this at your company using free and open source tools. But before we get into it, a little bit about us. So my name is Clint. I'm currently the head of security research at R2C. And before that, I was a research director and technical director at NCC Group, which is a global consulting firm where I did pen testing, as well as helping companies scale their security with security automation, as well as DevSecOps practices. Before that, I was an indentured servant, grad student at UC Davis. And today I'm joined by Isaac, who is one of the co-founders and CEO of R2C, previously was at MIT and MIT Lincoln Labs. All right, so here's a big picture what this talk is about. So first, we're going to give some sort of background and motivation about why bug finding isn't the answer. Then we're going to talk about how to eradicate vulnerability classes, sort of a high-level methodology of how to do so. And then we're going to get into the nitty-gritty in a bit more detail about how to actually do this in practice using the right tools and techniques. And then finally, we'll talk a little bit about the sort of future of security and where we believe things are headed, and how security teams and framework creators can collaborate. All right, so first, why bug finding isn't the answer. So in the past 5, 10, and 15 years, software development has changed a lot. And because of that, security teams need to as well. Based on chats I've had with friends of mine at many different companies, there's sort of this new reality many security teams are facing. Specifically, security teams often can't hard block engineering. That is, if there's something developers want to do, very rarely can the security team say no, unless it's something very important and critical. Security can no longer be point in time, it must be continuous. And many security teams are focused on building, like security engineering, rather than just breaking and finding bugs. And no longer are security teams sort of like this isolated, working on their own type team and force within a company. Often now they are embedded or at least partnered closely with development teams. So because there's all these changes in how things are working, I think that it's important for us to revisit our prior assumptions about how to be most effective as security teams in supporting our company's mission, given that the world is very different than it used to be. And I think there's some analogous things in just sort of broader tech in general. There's been some significant shifts from how we used to do things to how things are done now. Here's a couple of examples. So we used to use waterfall development, where programming happened over long periods of time. And now there's this big adoption of Agile, where things are rapid and iterative. Previously, there was very separate dev and ops teams. And now many companies are embracing DevOps, where these functions are partially or wholly merged. Previously, many servers for your company were probably on-prem, but now there's this massive adoption of the cloud. So in all of these cases, it hasn't been sort of an immediate jump from the left to the right side, but there has over time been this gradual shift as we as an industry realize, hey, there's actually a lot of benefits to doing things a very different way. And I think there's a similar, equally important shift happening in security, where previously we were focusing on finding vulnerabilities, but now, based on talks I've had with a number of very forward-thinking smart security teams, we're instead leaning towards secure defaults and invariants. And what I mean by invariant is just a property about the code or the system as a whole that must either always or never be true. And what we're going to talk about is how, by setting strong invariants, this is going to let you significantly de-risk systems and really have some nice scalable security wins. And sort of the key insight here is that when you don't need any context to make a decision, like in this case, we always either block or deny, for example, this requires no operational time for the security team, which lets you sort of knock off a bunch of different wins and then focus on other things. So again, becoming more leveraged with your time. Okay, so I'm going to give you a couple of motivating examples. So let's say I gave you a random web application that you've never seen before and asked you, does this have cross-site scripting in it? So knowing nothing about it, you probably would have a number of questions like, okay, well, what can the user provide? What's the structure of that data? Is it just like numbers? Is it strings? Is it sort of arbitrary JSON data? Once the web app gets it, is this input filtered before it's stored to the database? How is the information stored in the database in terms of, is it converted to, say, integers and floats? Is it strings? Is it arbitrary JSON data? Maybe we care about if it's MySQL versus Postgres. When the data is returned from the database, does the web application do any additional filtering and processing? Does it output encode it? When it's sent to the browser, where is the user input included in the page? Is it in HTML or an HTML attribute or JavaScript or all sorts of things? So to be able to reason about the security properties of the system, there's like a lot of questions we have. But what if I were to instead say, hey, we've enforced this invariant on the code, that is, all of the front end is React, and we banned the API call dangerously set inner HTML. Now, React is a great example of a secure by default framework where it's essentially impossible, or at least very difficult, to introduce cross-site scripting at all anywhere, except for a handful of places where you can basically opt out of the framework protections, dangerously set inner HTML being one of those. So if I were to tell you that everything is React and we've basically banned all of the places where you can do something dangerous, probably a lot of these questions that you used to have are suddenly a lot less impactful because we've sort of mitigated classes of risk and sort of broad swath, lots of things we don't have to care about as much anymore. So similarly, let's say I gave you a random app that had and asked you, hey, does this have remote code execution issues in it? So similarly, you probably have a number of the same questions, but also perhaps you would want to know, does this app deserialize data? Does it run shell commands as sort of subprocess shell exec type things? Does it perhaps mix data and code using eval, exec, or other things? But again, let's say that I have set a strong invariant where I have banned calls to exec and eval, and there's no way to do shell commands, and it doesn't deserialize anything. So then probably a lot of these things that you used to be worried about are significantly less risky. And I like to think of this as, let's just solve the easy version of the problem, right? So these apps could be incredibly complex with millions of lines of code, but with some strong invariants, some strong properties that we are enforcing, we've significantly reduced the risk of these applications, even though there's a lot of things we might not necessarily know. An important point is we did this, without very fancy, complex tools, right? So we didn't have a very powerful dynamic analysis tool, DAST, that can handle, modern web applications and all the intricacies that entails. We didn't use a SAST tool that could do complex interprocedural data flow analysis, tracking, tainted user input across dozens of files and maybe millions of lines of code. We didn't do fuzzing or symbolic execution or formal methods like proving the correctness of the code. We were able to make strong guarantees about the security properties of our system without all of these heavyweight approaches. So one way I like to think about this is the task versus the effort required. So on the y-axis, we have the effort required in CHUs, which is Clint's hand-wavy units. And basically, in the lower left-hand side, we see detecting either the use or the lack of use of a secure library. Computationally, that's pretty easy, right? We don't need a lot of contextual knowledge. We can just sort of look for the APIs and function calls being made. So that's pretty easy. But if we want to find something that's potentially a bug, then we need to do a bit more of analysis. Probably we need to reason about how user input either can or can't get to that vulnerable code location. And then it's even more work to confirm whether that potential bug is actually a bug. And then it's even harder than that and takes more work and more either manual and or analysis complexity to write a proof of concept exploit code for that, demonstrating that, yes, not only is this vulnerable, like here's something that actually attacks it. And fundamentally, what I'm trying to get at here is detecting the use or lack of use of secure defaults is just so much easier than finding bugs. But if you have these strong secure defaults that make exploitable bugs impossible, or at least very difficult, then you don't necessarily have to find all the bugs because they just can't happen by construction. So we wanted to make sure to connect with the youth these days. So we included this meme. So we would say broke is finding every vulnerability, and woke is preventing classes of vulnerabilities. All right, so you might be thinking right now, like, cool, like I kind of buy into this, but really all you've shown me is some sort of hand-wavy diagrams. And the security industry has focused on bug finding for decades, right? Building very powerful, impressive SAST and DAST tools, spending a lot of money on pen tests and bug bounty. And you might be thinking, yeah, this is just your opinion, man. So we wanted to give you a number of examples of other companies who have come to similar conclusions. So first, this is a talk by Patrick and Asta of Netflix a couple of years ago. So on the left-hand side, under de-emphasized, this is their priorities for their AppSec program. They are de-emphasizing manual testing, so manual sort of like pen testing, as well as traditional vulnerability scanning. And then on the right-hand side, heavily emphasized is a paved road that is secure defaults and killing bug classes. This is another talk by Scott and Isha, also of Netflix. So the following year at AppSec Cali, notice how secure by default is a core part of their security program, and notice that it's only growing over time. Earlier, we were talking about, hey, like banning functions can be very powerful, and you might be a bit skeptical, like how much is this actually valuable in practice? So one interesting study, so Microsoft crunched the numbers, and they found that when going from XP to Vista, 41%, or that is almost 50% of all the vulnerability reduction in that transition that happened was basically from banning store copy and a number of other dangerous functions. So that's a pretty impressive bang for your buck for essentially just banning a few functions. And a more recent blog post from the Microsoft Security Research, Response Center, tools and guidance, that is like developer training, are just fundamentally not preventing memory safety issues. They have represented the same proportion of vulnerabilities assigned to CVE for over a decade, right? So Microsoft is saying we've spent a huge amount of time building powerful like static analysis tools as well as fuzzing and training developers, but ultimately, we still have these same issues. Google recently released a quite excellent book for free online called Building Secure and Reliable Systems, and here's a snippet from it. They say it's unreasonable to expect any developer to be an expert in all of these subjects or to constantly maintain awareness of all these security issues when they're writing and reviewing code. A better approach is to have frameworks, languages, and libraries that make common security vulnerabilities impossible. So I like both parts of this, but I want to focus on the first for a second, which is I think in many cases, our expectations for developers are a bit unreasonable, right? We expect them to build new features and provide value for the company, both quickly and write scalable code that is correct. And as they're doing all of these things, we also expect them to be aware of all these security things that could go wrong, even though we as security professionals have spent years, perhaps even decades, becoming more familiar with it. So I think ideally, and what this talk is focused on, is like, how can we make developers just not have to worry about security and instead just go about their jobs, and just transparently the security team is supporting them and making them able to do their job easily as well as securely. So Facebook had a blog post, Designing Security for Billions, where they present sort of this pyramid, but it's sort of upside down, where the base, sort of the bulwark of the whole thing, is secure frameworks that they try to use to prevent and remove entire classes of bugs. And they use other things too, right? Like automated testing tools and peer review and so forth. But sort of the base, the thing that they aim to catch the most bugs with, is these secure frameworks. Okay, so you might be thinking, this is great and all, but like I'm not Google, I'm not Netflix, I'm not Facebook. But you don't actually need to be these companies to get this value. So you can get a lot of the value by choosing modern web frameworks and well-supported libraries, which can in themselves just mitigate entire classes of vulnerabilities. So if we think back to early 2000s, web security was really a wild west. Cross-site scripting and SQL injection were everywhere, or at least quite prevalent. And once frameworks started outputting coding by default and encouraging the use of ORMs, or object relational mappers, a lot of these issues gradually, they didn't completely go away, but they became much less prevalent. So by using modern frameworks, as well as secure by default libraries, I've included a couple of examples there. You too, even without a massive, well-resourced AppSec team, you can get a lot of the same value. So it's not out of reach for you. OK, so let's talk now in a bit more detail how to eradicate vulnerability classes. So in this section, we're going to present a methodology and walk through each step. But before we do that, just quickly to zoom out for a second, why do we care so much about killing bug classes rather than sort of one-off bug fighting as we've sort of traditionally done as an industry? And the reason is that there's these huge compounding effects of killing a bug class and not just a one-off bug here and there. And let's say, for example, you are a part of an AppSec team and you do sort of a time audit to try to figure out, OK, where do we spend our time? And let's say this is a hypothetical example. You're like, OK, well, we spend a fair amount of time on cross-site scripting. We also do threat modeling and training and so forth. So let's say you were able to, say, work with the engineering team and port everything to React or do other secure by default mechanisms to essentially kill cross-site scripting. And then maybe it still happens every once in a while, but you essentially have to spend little ongoing recurring time on it. Then all of that time you used to spend addressing cross-site scripting, you can then focus on something else, perhaps SQL injection. And by gradually eliminating all of these things you used to care about, you become much more leveraged and highly scalable as a security team, where you just knock off more and more problems even with the same number of people and not having to work crazy hours. OK, so let's talk about the process itself of how to eradicate vulnerability classes. So first, we're going to evaluate which vulnerability class to focus on. So there's many things you could do, which is the thing that's best to focus on first. Then we'll talk about determining the best approach to find or prevent a given bug class at scale. We'll then discuss how do you select what the safe version should look like and how can you make it the default? How can you train developers to use this safe pattern? And then finally, how can we use tools to enforce the safe pattern so that basically we have these strong invariant guarantees across many repos. So there's many ways to decide on what you should focus on first. Here's a couple of example criteria that different companies use, but ultimately it's up to you and what makes sense in your environment. So one thing you could do is focus on the bug classes that are most prevalent, so what's happening the most places. You could also focus on the bug classes that have the most impact or risk. So for example, let's say your company has a lot of information disclosure type issues, but usually they are either informational or low risk. Then you might want to focus on bugs that are less common but more impactful. Some bug classes may be easier to tackle, either from an organizational buy-in point of view or just technically it's easier to fix. And maybe your company has certain priorities itself that you can abide by. So realistically, you probably want some sort of weighted function of all of these. But again, the important thing is just what makes sense for your company and your circumstances. So in order to do this process, we're going to need a nice data set of vulnerabilities that have happened in the past so that we can review them and look for trends. So in order to do that, you need a strong vulnerability management program. So you need to know, OK, what are all the security issues we've had in the past and what do they look like? This allows you to know your current state, where are we now, as well as if your future efforts actually work, right? So we're going to be doing a lot of work and a lot of initiatives that I think are high leverage, but you want to be able to prove to yourself, as well as upper management, hey, the things that we're doing on are measurably improving our security posture and deserve additional focus. So there's lots of things to track. Here's just a couple of examples. So ideally for each security issue, was this a low, medium, or high risk? What was the vulnerability class? Was it related to access controls or XSS and so forth? So I encourage you to create a taxonomy for your company. I think OWASP top 10 is a little bit too narrow, but something like VRT is maybe a little bit too broad. I would aim for maybe 20 to 40 categories. You want each sort of bucket of vulnerability class to have a different root cause and fix. So you want enough that you can differentiate between different bugs, but not so many buckets that every bug is in sort of its own bucket, because you want to be able to look for trends. Ideally, you also have the pull request either introducing and or fixing the issue. So you want to know like what does the buggy code look like and what does the fix look like? And then you also want to know what's the relevant code base and sort of the team and org responsible. Okay, so in most companies I've worked with, you don't necessarily have this like super nicely groomed list of vulnerabilities to review. So you have to do some manual work to try to create this input set into this process. So here's a couple of things you can do if you don't have a nice set of vulnerabilities. In the future, it can be better, but for now, like let's start with what we have. So many companies have a specific tag, either for Jira or GitHub issues, that's like, hey, this is a security-related thing. So you can search for that if you have it. You can also create a list of security-relevant keywords, such as vulnerability, XSS, SQL injection, security, hack, or something like that, and then search every pull request and issue in Git commit history for those keywords. You can use like get log and then pass in one of the keywords, for example. If you use security tools such as SAST and DAST, this is another great source, as is pen test reports, bug bounty submissions, or even just asking development and ops teams or other security teams like, hey, what sort of issues have we had in the past? Can you point me to anything? And so again, like fully analyzing all of your ad hoc historical data, this could be a time sinkhole, so it might not be worth doing it to the nth degree. Just do it enough so you have at least some input data. But what you can do now is create and document a lightweight, and by lightweight I mean something that you can continuously do over time. It's not going to be so much of a burden that you stop. Standardized process where you track this vulnerability meta information going forward. So yes, you might not have exactly the data you want now, but you can do things now that make, say, 1, 2, 3 years from now, you much better informed and data-driven as a security program. Okay, so once you have this input set, I would encourage you to slice and dice it. You could group by vulnerability class or what found it, and maybe you want to weight by the severity and risk. So one example of a number of things you can do once you have nice vulnerability data was described by Arkady in his talk, Data-Driven Bug Bounty. So this is just one of the figures from the talk. I would encourage you to check it out. But you can see here, like, oh, security misconfiguration and sensitive data exposure, these seem to be the most prevalent issues. So maybe we want to focus there, or at least examine it. Okay, so once you have a couple of bug classes picked out, review the fixes and ask yourself questions like, okay, what did the vulnerable code look like? What did the fix look like? And what sort of trends can we see? So ideally, in the best case, all of the vulnerable code looks similar, and this is going to allow us to generalize and target it. And then in the worst case, every instance of a bug, for example, cross-site scripting, has like a different source and a different cause. So in that case, it's going to be a bit hard to generalize and stamp it out, unfortunately. So again, going back to our common selection criteria, in an ideal world, you're going to be able to choose a vulnerability class that is widespread across many teams and repos. It's high risk. It's feasible to get developers to fix it, and it aligns with your company priorities. And again, it's always broken in the same way. So realistically, probably not all of these are going to be the case for every bug class. But if you can have at least, say, a couple of these or most of them, it's going to be much easier and better for you to target those vulnerabilities. Okay, so one thing I wanted to point out is depending on what the weakness and what the vulnerability is, there's different approaches that are going to be better or worse. So for example, let's say there's some sort of big picture architectural flaws that keep biting you. Well, then you probably want something like threat modeling, because those sorts of issues are related to how things fit together and not necessarily something that's obvious from the code. So you might want to do threat modeling. But in this talk, just for the sake of time, we're going to focus on, okay, when we have known good or known bad code, how can we address that with lightweight static analysis? But again, just the key point here is there's many types of issues. Don't try to apply the same approach to every issue, because it really depends. Some are much better or much worse, depending on the situation. Okay, so step 3 is we want to select a safe pattern and then make it the default. So how do we know what a safe pattern is? Perhaps your company has internal coding guidelines already, or you want to align to a standard like NIST. Maybe you have your own expertise. But I would also encourage you not to reinvent the wheel, right? So OWASP has a number of great resources, the cheat sheet project, as well as ASVS. Why not learn from sort of the best the industry has written over time? And then the second part of that, how do we make it the default? So we want to update various internal coding guidelines used by security as well as developers, so that whenever someone goes to say, oh, how do I do this thing, they come across the secure by default pattern that we have created for them. So this means updating things like READMEs, developer docs, wiki pages, facts, training slides, onboarding presentations, and etc. So the key thing here is like explaining why these patterns exist and also how to use them, because you want people to have the right context to know why this is important. I would also encourage you to potentially work with developer productivity teams. So in medium and large size companies, sometimes there's whole teams dedicated to making the rest of engineering more efficient and productive and cohesive. So they probably have some very good feedback and can help you on how we can make the secure version have an even better developer user experience than the old way. This is key to getting adoption. And again, fundamentally, like how can we make developers more productive and secure? Another important tip is if you integrate security at the right points, for example, in new project starter templates. So say, for example, there's a Git repo that every developer in your company will fork to create a new microservice or a new sort of internal component. If you put the secure defaults into there, then everyone who uses that repo, which should be everyone if that's sort of the expected practice in your company, you get this automatic widespread adoption of secure defaults without you having to encourage anyone to do anything because it's just already there. And a quote I like from Asta very much is, hitch your security wagon to developer productivity. Because ultimately developers want to move fast and get more features done. So if we can enable them to do that, of course, they'll do it. Okay, so step 4, train developers to use the safe pattern. So how can we make communication successful? So we want the what and why something is insecure to be very clear, using terms developers understand, not like don't do this because cross-site scripting. Like the impact of that might not be clear. And if we can convey the impact in terms the developers care about, for example, risk to the business, damaging user trust, like SQL injection might sound scary, but it doesn't necessarily mean anything. But say having an attacker stealing all the private messages or photos for someone, like that is more viscerally impactful. Maybe appealing to like reliability or uptime. These are also important. And again, you want the how to fix to be concise as well as clear. What should they do? And you want to link to additional docs and resources with more info. And maybe if you have Teams or Slack, you can have a channel dedicated for developers asking questions. So a talk that I really like by Morgan Roman called Don't Run with Scissors, he also talks in detail about how to get adoption of secure defaults. So I highly recommend you to check out this talk. But one sort of meta structure he has he recommended for communicating to developers is, if you use this bad thing will happen. Instead, do the good thing, and it stops the bad thing. Here's an example of what not to do. Here's what to do. So again, straightforward, but I think it emphasizes clarity and actionability, which is great. Okay, so step 4, train developers to use the safe pattern. So there's a couple things you can do. Oftentimes developers have onboarding sessions with a number of teams, including security. This can be a great way to start making some friends and make people aware of you. You can have educational brown bag sessions over lunch where people can listen about security. Internal CTFs is a great way to get developers excited about security. You can have a security champions program. And then when in-person interaction is more feasible, you can grab lunch with development teams and or schedule a happy hour. And finally, I've heard this from a couple of companies, but having candy on the desks of the security team is one of the highest leverage ways to hear what developers care about and to make friends. Heard this from a bunch of people, so give it a try. And finally, after we've done all these things, we're going to use tools to enforce the safe pattern. So essentially, the short story is we're going to use lightweight static analysis, that is grep or linting, to ensure that these safe patterns that we've defined are used. But I'm going to pass this off to my colleague Isaac, who's going to talk about making this real in a lot more detail.
Great. So we just heard from Clint a whole bunch of very specific steps about how you can eradicate vulnerabilities in your application. And what I'm going to do is take us through those steps again as a quick recap, and then go into some very specific applied tools and techniques that we can use to actually effectively make them real. So just as a reminder, because there was a lot of content in the previous section, there were 5 steps to eradicating vulnerabilities. The first one was evaluating which vulnerability class to focus on, then determining the best approach to find or prevent it at scale. Next, selecting a safe pattern and making it the default, then training the developers to use that pattern, and then finally using tools to enforce the same pattern. So I'm going to zoom in on 2 of these specifically and show you first how to set up continuous code scanning and what the best practices are for that. And then for the last one, show you how to check for what are effectively escape hatches inside secure frameworks. So let's look at the first one, continuous code scanning. This has actually been covered a lot, both at AppSec USA over the years and at other DevSecOps conferences. So we're going to link the slides at the end of the presentation, and you can refer back to these as a reference. What I'm going to try to do is just distill down a couple of the core principles that I think are in common across all of these presentations for you to look at. So the best practices that most of these presentations agree on are, first off, the unit of scan ought to be the pull request. So there's too much variance in how developers treat commits. Sometimes people, will commit very, very frequently. Sometimes they'll commit very, very infrequently. But generally at pull request stage, a developer is saying, hey, we're merging code. We would like a feature review here. I'm looking for feedback from my peers, and it's a good time to get feedback from the security team as well. The second thing is you want to scan fast. And when I say fast, I mean ideally less than 5 minutes, really no more than 10. And the reason for that is that this is giving feedback while context is fresh. No one wants to come and have to reload all of the state into their head a day or a week later. That doesn't preclude you from doing longer scans, that are more in-depth on a different frequency. And in fact, one of the other best practices we see is that there's often a recommendation to have 2 separate scanning workflows. So a first workflow, which is for auditing, and that's basically visible only to you on the security team. And a second workflow, which is actually blocking, which will either prevent a merge or show things directly to the developer. And another principle that most of these presentations have in common is that it's really important to make adjustment easy. So you're going to be setting up this flow. You're going to want to iterate on it a lot. So you want to make it really cheap to add and remove tools. And even within those tools, you want to make sure that it's really cheap to add or remove new rules. So if we look at a really specific example of what this looks like, this is an excerpt from the Google Tricorder paper. So Tricorder is Google's internal code review system, and this is how both security and non-security findings are integrated into the system. So I think it gives us a helpful illustrative example that we can pull out some of the best practices that those other papers were talking about and look at them really specifically. So the first thing you'll notice is that we're showing the tool finding within the developer system. So we don't have, hey, like some ID fired at this line of code. Instead, it's in line where we're looking at the code. The message that's being displayed is clear and actionable. I actually think this one could be a little more actionable. And it has a link to more information. And then we're actually, these 2 buttons, please fix and not useful, the hyperlinks there, those are not for the security team, those are for the developer. And based on what the developer clicks, there's going to be metrics captured about the check type, the scan runtime for it, and also the true or false positive rates, because Google will interpret clicking not useful as a false positive. And then the final thing that they're going to do is track and evict low signal checks. So the general recommendation here is you want 95% true positives or better. Otherwise, you're basically just going to burn credibility and goodwill with the developer team, as well as creating a tremendous amount of extra work for yourself, which is not valuable. So what are we hoping to continuously find? Well, this presentation has been about eradicating vulnerabilities. So the whole idea here is, all right, if we're using secure frameworks that maintain invariants, then all we need to do is detect the functions that let you escape from those invariants, aka escape hatches. So for instance, earlier in the presentation, we were talking about React. The escape hatch that we'd like to find in React is dangerously set HTML. If we're concerned about remote code execution, the escape hatch from our memory safe language is a function like exec. So specifically, how are we actually going to find escape hatches? And there are a couple of options here. The first one, which might seem crazy to you, but I've actually encountered a lot of really good security teams who have gotten a lot of leverage out of it, is grep. So grep is easy to use, it's interactive, it's fast. Most people know regular expressions already. And if we're just looking for a function named exec, it's going to do the job. It's going to potentially trigger on some things that it shouldn't. And that's because of the con here. It's line oriented, so there's a little bit of a mismatch, well, a pretty big mismatch between a textual tool and the tree-like structures of programs. So the abstract syntax tree, if you're familiar with the term, which is why many people will either use or build a plugin to a code-aware linter, which I've listed here as the second option. So the pro there is that we're robust and precise. We're going to handle white space properly, comments properly. The con, is that each parser represents ASTs differently. So we have to learn, for each language that we want to use, we have to set up a parser for it. And then we have to figure out how that parser represents the AST nodes that we care about, which is a pretty significant amount of overhead and requires some expertise. So is there anything else in this category? Well, in fact, there is. And actually for that, we turned to an early Facebook tool that was made when Facebook was a much younger company, which actually formed a lot of their early program analysis infrastructure. So full disclosure, this is a shameless plug because we at my company are now the maintainers of this tool, but it's still open source and we love it. So it was originally developed at Facebook. It's called SymGrep to encourage secure code patterns. Basically, it's customizable, lightweight, static analysis tool for finding bugs. We've been building a community around it, and you're going to hear about some of the OWASP collaboration that's happening later. But basically developing hundreds of existing community rules. And the whole idea with the tool, which you'll see an example of in a second, is to combine the speed and customization of grep with the expressiveness of more of a traditional static analysis tool. So it runs online, doesn't require compilation, it's open source. And one of the coolest things, I think, is that it doesn't require you to learn some very complicated domain-specific language. Generally, the patterns you're going to write are going to look very similar to the source code that you're targeting. And you can see the supported languages there. So the pros to SymGrep are, it is very good at handling languages with more than one way to do it. So if you are targeting a language like Ruby, where there's 4 ways to call a function, you can write one of them and SymGrep will figure out all of the equivalent variations. And it's a single tool for multiple languages with a relatively simple pattern language. The con is going to be that it's slower than grep, and of course, not all languages are supported, unlike with grep. So what does that actually look like? If we go back to the exec example, say we're trying to prove that our app doesn't have remote code execution, you can just invoke SymGrep on the command line with -e and then the expression that you want to find. So in this case, the expression is just exec left paren ... right paren. So this is there are 2 sort of extensions to the programming language that SymGrep provides. The first extension is this ... operator, which is kind of like a wild card or a .* in grep. And it's basically just saying, I don't care whether there's 0 or 1 or more arguments to this function, just trigger on all of them. And you'll see that compared to, if we were just doing a dumb grep for the same sort of thing, we're missing line 8, line 16, and line 18, which is exactly what we want. We don't want to be triggering on some exec. We don't want to be triggering on commented out code or code that is inside a string. And what's really cool, I think, is that if you look at line 1, SymGrep is actually properly mapping through this import. So if you don't know Python, the developer is importing exec, they're renaming it to be safe function, and then they're calling safe function. But SymGrep is smart enough to kind of track through that import aliasing. So that's really cool. That was a fairly basic example. If we look at a more complex example, here we have, like an equivalent sort of thing in Java. But in Java, the exec function only matters if it comes from Java Lang runtime. So in this example, we're using the SymGrep expression to actually specify some placeholder for the variable name. So it could be RT or it could be other. In this case, capital $X is just a placeholder for, hey, I don't care what the variable name specifically here is. Then we're using the same sort of pattern. You can see we've specified the type. And this is triggering on line 7 and 9, but not on line 12, where another object with a method named exec is being called. So that's cool. And there are some links down here that you can go play around with if you're looking at the slides and just try it out in an interactive live editor, or you can run it offline on the command line. What's really interesting about a tool like SymGrep is that it lowers the bar so much to writing something that is effectively a custom static analysis tool that you can start to add your own business logic checks. So let's say, for instance, that you have an application where that a developer should always be calling some function named verify transaction before they call make transaction. Here are the SymGrep patterns that you would use to enforce this on your code base. So you can see I'm actually, in this case, combining two patterns. And if you click through to the try it and solution things, you'll see exactly how this works on a real example. But basically, I'm just saying, hey, I want to find any code. And you can see I'm using these ... operators to say I don't care about what happens before or after this line. So any function that calls make transaction, but is not a function which has verify transaction coming first. So that's pretty cool. And I think the real power of this is, at the most base level, if the developers don't actually love the security team, all of this work for trying to eradicate vulnerabilities and secure defaults can be compromised. So here's an example from the British government's evaluation of the Huawei source code, where they found that developers had used a pound define to basically redefine the name of a safe function to be the unsafe one. So the real takeaway here is, all right, like all this great, like eradicating vulnerability static analysis tools, it doesn't matter if we don't consider the psychology of the developer. So what we need is 3 simple ways to make developers love you. And hint, it's not finding more vulnerabilities in their code. I'm just gonna run through, like kind of collating across all the things that I've seen, what are those best practices from a tool that is trying to inspect source code for vulnerability eradication. So the first thing is to be fast. We covered this under continuous scanning, but now we're considering it from the developer's perspective. And really, I think the takeaway here is don't come in last. So security checks should not be the slowest thing blocking the developer from merging. It's okay to be slow as long as you're not as slow as the build and the other checks that are going to be required to prevent the developer from getting the dopamine rush of clicking that green merge button. The second thing is to be early. If you are going to make me fix something, as a developer, I want you to tell me as soon as possible, ideally in the editor. Here we have a Visual Studio Code with a SEMGRUP extension installed on the right. And the third thing and last thing is people love easy buttons. If you can provide an auto fix and just make the process of fixing security problems fast and easy, even if you don't have a perfect patch that is just like click to apply this fix and it's actually going to perfectly fix the code, even an imperfect suggestion is a lot better than nothing. So we've actually extended SEMGRUP since its Facebook days to have support for some auto fixing. You're seeing an animation of that here down below. And one of the cool things is the same sort of pattern language that you use to specify the query can be used to specify the fix, which is really cool. So we've covered some applied techniques and tools for actually making this real with your interfacing with the development team. What about interfacing with the sorts of people who develop frameworks? And one of the coolest things I think is that again, referencing building secure and reliable systems by Google has actually mapped every OWASP top 10 vulnerability to a framework hardening measure. So there's something that you can do at the framework level for each one of the OWASP top 10 vulnerabilities. And in fact, we've been working with OWASP specifically on this. So SEMGRUP and OWASP have been collaborating on ASVS and the OWASP cheat sheets. So the goal here is to get out of the box support for like, hey, there's a tool that you can just run, which will verify, is my code compliant with ASVS level 1, which was specifically designed to be automatable? Or if you're reading a security cheat sheet from OWASP, you can have a rule set that you can just use to run and say, hey, like, I have a project, I'm looking at this cheat sheet. Is there any code here that violates the cheat sheet recommendations? And I'm really excited about this because I think it gives us an opportunity to kind of codify in a really automated way a lot of the great domain knowledge that we have as security experts and make it more accessible to a larger number of people by having it actually be not just a cheat sheet that you can read, but a cheat sheet that you can execute or a standard that you can execute. It really starts to, I think, just make it much easier to distribute that security knowledge rather than having it locked up in a wiki. So yeah, in conclusion, if there's just a few things that you take away from the talk, let it be this. First off, secure defaults are the best way to scalably raise your security bar, not by playing bug whack-a-mole. Second, killing bug classes is going to produce compounding results. It's going to make your AppSec team more leveraged. And the way that you should do that is by basically defining a safe pattern, educating developers as you roll it out, and then figuring out a way to enforce it continuously for which you're going to need fast and lightweight tools. SimGrep might fit some of your use cases there. And you're really going to want to focus on the developer experience with that tool. So I hope you've enjoyed our talk on eradicating vulnerability classes. We would love to chat with you from the OWASP cheat sheet side or the SimGrep side, whatever we've presented that could be useful. And we're going to be posting the slides at the URL below. Go out and eradicate some vulnerabilities. Thank you very much.